Okay, good evening everyone, and welcome to today's live stream, which is going to be again about PicoCTF. This is the 11th live stream about PicoCTF 2019. Oh, and I can hear myself on YouTube, which means it works, which is perfect. Okay, so yeah, 11th live stream. We still have several tasks to do. Last week we managed only to do one because my internet connection was dying. Then it was dying all until I think yesterday, maybe 2 days ago. There were like some Europe-wide UPC problems, so that was pretty weird. But yesterday it was pretty stable, so I hope today is going to be stable. Let's see, and let's hope. We cannot do more than that, I'm afraid. Cool, so today's moderator, it's surprise, surprise, Foxtrot Charlie. You can see his nickname right there. So if you have any questions to me, you need to ask Foxtrot Charlie. You need to ping him on YouTube chat or Discord. Or if you are on our IRC, it's enough if you type !Q and then the question. And whichever of these you will do, the question will reach me. Now, you do need to ping Foxtrot Charlie in case you want to send me a question, because I'm not always looking at the chat, so I might just miss it. So it's best like if you give him the question and he will put it on my question list, which I can later at like some convenient time actually go back to the question and answer it, or just say I have no idea and move to the next question, the usual. Perfect. So what should we talk about first? Let's go maybe to... No, this is too early for that. This is Foxtrot's website. Visit it because it's cool. And thank you, Foxtrot, for helping me with the live streams as usual. Now, page layout is delayed. The work is still going on. If you're interested in what does retooling actually mean, which is the excuse I've been using for delaying this issue, the third issue. It means basically building a review center where we can put an article, like an author can put an article, and then reviewers and lead reviewers can look at the article, comment on it. And yeah, I pasted some screenshots a few days ago on our paged out chat, because we have a chat on my Discord. And it's basically, this is how it starts to look like. You basically have an article, you can mark pieces, you can discuss the pieces with the reviewer, and after everyone is happy, the article is being sent to being put together and we get the next issue. This is basically the plan. We are getting there. We are still, sadly, some days, maybe even weeks away from being able to start the work on issue 3, but we are getting there, and the system will allow us to hook up some automated systems which will check stuff like font licensing. This is going to be later on implemented, because this is actually a really hard problem for interesting reasons. We might chat about that someday. Like, how does the article look like after applying the header and the footer? Which we add. How does what is the size of the article correct, and so on and so forth. So everything will be in one place, and this is basically how it's starting to look. And I guess you can get a sneak peek of the cover art for issue number 4, which is just part of it. It's actually really amazing, and yeah, I will be happy to share it with you as soon as we start working on issue number 4. And there will be an issue number 4, do not worry about it. We are not going anywhere with the project, as in we are not going away, because we are moving forward. Cool. Adblock plus upgrade, what? No. Okay, so challenge problems, let's see what we have to do. And if there are any questions, again, you have to ping Foxtrot Charlie and we can answer them. I can answer some questions now, or we can answer some questions later on. So we have, 78 challenges solved, and we have 22 left unsolved. So let's click and focus on the unsolved ones. As usual, I am skipping forensics for now. We will leave this to the end, until the end. And we have reverse engineering, we have binary exploitation, and we have web exploitation. We might be able to do all, well, these three today. And yeah, I guess we are moving forward. Again, if you have any questions, you need to ping this guy on YouTube chat, like that's @Foxtrot Charlie and then the question. That way he gets pinged. Same on Discord and same on IRC. Though on IRC you can just write !Q and then the question. Perfect. So I guess we can start with the challenges. This is what? Reverse engineering Java. The Vault uses XOR encryption scheme. XOR is actually an unbreakable encryption scheme under one condition, that the key is the length of the secret and it's properly randomly generated. In that case, it's unbreakable. Like really, it's called one-time pad and there is no way to break it, period. But that is, like, there's still the problem of how do you securely transfer the key, which means this isn't really super useful in reality. And usually XOR encryption scheme does not mean one-time pad, which I just described. So we are going to start with this one and have some fun with it. Perfect. It's called Vault Door number 6. We already solved multiple of these, so I'm looking forward, like 5 other Vault Door challenges. I'm looking forward to solving this one as well. Let me open the source code. The source code looks like this. So let's analyze the source code. I guess we can do this. So we have the main function. We get the password in. Then we add the... we remove the PicoCTF. And yeah, we basically get the middle, well, anything which is in the middle between the curly braces. And then we check the password. And then we have some story. Dr. Evil gave me a book called Apply Cryptography by Bruce Schneier. I'm pretty sure I have it on my shelf, by the way. I might even have it with a signature of Bruce, because I had the pleasure of meeting him on some conference. And I learned this really cool encryption scheme. This will be strongest vault door in Dr. Evil's entire Evil Volcano compound for sure. Well, I didn't exactly read the whole book, but I'm sure there's nothing important in the last 750 pages. Minion number 3091. And this is... the password has to be 32 characters. Then it gets the password, there are some bytes. And then it XORs... okay, so in honesty, I was expecting that we will have to, for example, break a 7-byte XOR key or something, and it seems the key itself is actually just 1 byte. We have these bytes, so what we have to do here is we have to, each byte is being XORed with this value, and then each byte of a password is being XORed with this value, and then this is being subtracted, and it's checked if it's 0 or if it's not 0. So, subtracting something from something is another way to do comparison. Actually, like in assembly, for example, if you want to compare if whatever is in the EAX register, if it's equal to whatever is in EDX register, what you do is you do CMP, compare EAX and EDX. Now, CMP actually is doing subtract from EAX EDX, but without storing the result. And it's able to set the flags, like for example the 0 flag, and if the values are equal, then the result will be 0. And so you put 1 in the 0 flag, meaning yeah, it's equal. And otherwise it's going to be non-equal. So this is like this plus this is basically just, it's not a mathematical operation which is supposed to be related to the cipher. It's actually checking if it's the same. Otherwise we could move this here and get rid of this, change it to plus, move it here, and yeah. So it's something which people doing low level know. Otherwise it might be a bit confusing, why I am absolutely going to ignore that. that part. Apart from that, we are just going to, we just have to XOR this with the value 55, which I am going to do using Python, and I'm not even going to bother doing any kind of script file. I do not have IPython 3. Okay, I do not have IPython 3 because I did recently upgrade my Ubuntu. I spent several hours actually fighting with the repository to upgrade my old outdated Ubuntu to the almost newest one, almost because a day after the new version came out. But whatever, we will manage without IPython services. Okay, this was a fail, let's do it again. In IPython, this wouldn't be a fail, so we have this, we have the bytes. And now we are going to XOR each of them, so we will do this. We are going to, for each byte, which is B, we are going to XOR it with the value 55. 55 is a nice value, by the way, because in binary notation, it's 01, 01, 01, 01. So just 01, 01, 01, 01. Like a nice pattern. The other pattern, which is nice, is 10, 10, 10, and this is A. So sometimes you see like 55 AA or A5 or like 5A, these kind of signatures, and that means that somebody's playing with this bit pattern for some reason. I think like even at the beginning of a disk boot sector you can find this pattern. So let's do a quick check. Let's go to MBR, master boot record, but not the Polish one, the English one. Here we go. And yeah, here we go. This is the exact bit pattern. It's pretty common if you want to set some bit pattern for testing that you use these values. So I am absolutely not surprised by seeing this as an example XOR key, because it changes a lot of bits, but like not all of them. Okay, for B and K. So this is XORing them, and yeah, you can see that these values are pretty same. They are all in the ASCII region, the ASCII printable region. The printable region is from 32 to 126 without 27. All of these values visually, even without checking, seem to be in this region, which means we probably have decoded it. So we just join it. But before joining it, we have to convert it to actually a character. So we do this and we get not much harder than XOR. Yeah, and this is the flag. We obviously have to add like PicoCTF at the beginning, PicoCTF at the end, but we can do it by hand by going here. PicoCTF, this, and here we go. We have this challenge solved. So if you have any questions, let me know. I guess this was like super easy challenge. We had the source code. We could just like copy paste this, and yeah, nothing much to talk about, I guess, and nothing much to do. Perfect. Let's see if there are any questions. I don't believe there are any questions, which is fine, because we can move to the next task in that case. And yeah, I didn't expect you to have any questions after that one. We have binary exploitation called Afterlife. I think last time I said that this sounds totally like use after free. So let's check if this actually is use after free. We can do this, and we can also go on the on the shell, which I conveniently have here. We can go to this directory and see what's there. So as usual, we do have the flag, which is on a different user, and we have a sgid setgid binary, or rather a binary with sgid flag set, which means it runs with this group. So the binary has access to the flag, but we do not. So you have to exploit the binary to get access to the flag, because a different group. Perfect. Now we can see the actual source code, but before we look at the source code, I'm going to do what I always do, which is I'm going to do checksec on it, because checksec is a wonderful script. Checksec, I think it was file and then vol, and it says, sorry, let's do it again. Oh, we actually have NX disabled, so we can put anywhere in writable memory, we can put bytecode, or rather machine code in this case, and we can get it executed. No ASLR, we do not have to worry about things being in random places in memory because they will be always in the same place. And by always and things, I do mean the binary in this case, because other parts like the stack might still be in random places, or the heap. Partial reload we can ignore. Canary found, we will see if this poses a threat to us or if we should just ignore it depending on the scenario. So let's look at the source code. The stream is having pixelization issues even though I'm on 1080p, which is weird because I'm totally streaming in good quality, so that might be a YouTube issue. That's sadly out of my hands, so I cannot do anything. Yeah. Okay. So what do we have here? We have a win function, and the win function actually... The win function opens the flag file, reads it into the flag buffer. The buffer is a local buffer, and outputs it. It's typical to like PicoCTF. We've seen this function multiple times. And then we have only... Okay, I'm going to actually do a word wrapping here. This is rather an artificial, I guess that's piece of code taken from secure coding and C by... Okay. So we allocate 256 bytes and we say, oops, any developer copy pasted and printed an address as decimal, and we do print out the address as decimal. Then we copy the first argument, and this is going to be annoying. It copies the first argument into the first allocated buffer, assuming line buffer size. The line buffer size is 20, but it actually allocated a little larger size than 20. And now str and cat, this n here is supposed to point to that is like some kind of a secure buffer, but was not really true. Sorry, a secure copy. If I'm not mistaken, and we will check this in manual in a sec, in case it copies the full amount specified here, it will not include the null terminator sign. Otherwise it will. If it copies the maximum amount, it will not put it there, which is weird and dangerous behavior. So we might have to abuse that in some way. Yeah, like library functions are scary, all of them. Second, we have malloc, and third, and we allocate the like 100 hexadecimal bytes each time. Then we free the first one, we free the third one, and then we allocate again, but a smaller amount. Now I'm really wondering what kind of malloc implementation they have there, because this will... Okay, but whatever, you will write on the first after it was freed, and overflow will not be very useful. Okay, we are able to write in memory at the address where first was allocated. Now it's passable, but it's not. And then we do malloc. Yeah, this is typical heap exploitation. The idea here is basically that we are going to write yeah, this I might fail at this challenge because I don't do too much heap, and I'm not really sure what kind of heap they use, but the theory is that because we are okay, let's do some drawings. We are allocating the first one, and we can put whatever in the first 20 bytes. We can put whatever here. We do not control the rest, but that's basically it. We do not control the rest. Now we will allocate the second. The second is going to go here. Then we are allocating the third. It will probably be like put like this in memory, one after the other, probably. Second, third, fourth. Then we are fourth. Where's the fourth one? Here's the fourth one. Then we are freeing the first one, so this is now considered free memory. This is like free real estate. Then we are freeing this one. as well. And now we are allocating the 128, and the 128 might, option A, go here, option B, go here, or here, and option E, I guess in this case, go here, or here. Now, this one, I would say, is most probable. This one or this one. Sorry, but this should be like this kind of size. And then we get to write under the address of the first one. So we can write here, and we can write here actually the amount, any amount we like. So we can override with this blue color. We can start overwriting here whatever amount we want to overwrite. Okay, overwrite. Override, yeah, we can like overwrite everything because gets allows us to overwrite anything. And then we are doing another alloc. And the allocation is, it will probably try to go here, but when doing the allocation, each of these blocks actually has a header, especially the free blocks. If something has been freed, it means there is a simple structure written there which points to the next and previous free blocks on the size. Like your mileage may vary, it may really depend on what implementation of malloc is being used, what version of the libraries, but basically if something is freed, there's usually a header there, and because we get to overwrite this header with this one, the moment we allocate something, we will probably get the pointers which are there are going to be used. And they're going to be used to basically detach an element, a free element, from a linked list. If that's the case, we get a sol code write what were condition, which means we control a pointer and we might even control the value which is written to that pointer. And so we can overwrite some pointer in memory. For example, the address of exit in the got table, as we did on the last live stream, or like 2 live streams ago. So I believe this is what we'll have to do. So again, if we have a block and the moment it gets freed, there might be, depending on malloc implementation, but I think this is what we are going after, there might be 2 pointers placed here. We'll have to investigate what exactly is being placed here, and a length of like what's the size of this block. And this pointer is to like the previous free element somewhere in memory, and this is to the next one. And the moment we allocate it, we allocate this block, well, the pointer which is here and which points the other way, the other direction, needs to be changed. But since we actually say where the other pointer is, we can say that it's being for example, in the got memory area. Therefore, this address of exit is going to be overwritten with what? Well, if you detach something from a linked list, you update this pointer, which is currently pointing here. You want it to actually point to the next free element, which is this thing. And this value is taken from this part. So this is the what. This is the where. And this is the what. So this is the write what where condition. And usually, it also the exact same thing happens with this pointer, like there's a pointer here and it will be upgraded with this, which means the what has to be a writable location. This might be fun, but this is basically what we are going to try to do. So basically to wrap it up, to sum it up, we will try to play with these 2 pointers, which should be at the beginning, the first things which gets overrides. And we will try to set them to some values that they will point to the win location, so that exit actually calls win. So we will set this value to win, this value to the address of exit, and then we will allow it to trigger the malloc. And the malloc will make this detach this element of a list, actually writing both pointers, and therefore overwriting the exit address with the win address. I know I might sound confusing, But yeah, heap exploitation is confusing, and I'm not an expert in heap exploitation, so let's try to wing it, basically. Cool. So, the question number 723 is, how does this binary look like? Like what kind of binary is it even? It's a 32-bit binary, so I need to launch 32-bit IDA. I'm still using IDA. I could be using JIDRA or something else, but I'm using IDA. And here we go. IDA has loaded it. We know how it looks. What we need is, we need nodes. We definitely need nodes. We need the address of the win location. The win function is being placed on this address because this is where we will try to go. This is like the win function. Then we need the import table address of exit function. So we look for exit here, and we look where is it being referenced? It's being referenced here, exit, and yeah. This got PLT. This is the address where the pointer is that we need to overwrite. So got PLT exit entry is at this address. So this is basically, this is our what, this is our where. We want to write this value into this memory slot or address or whatever you want to call it. And now I would love to be able to debug it remotely. Can we debug it? Now, if you're wondering, yeah, we can debug it. If you're wondering, hey, if I can debug it, I can just like change in memory, like just to set then the what address, right? This address. And we want to cast it actually to, yeah. And we can just write the what value there, and it will give us the flag, right? We need to break main to do that. So we run, then we do this, and then we continue, and it actually segfaulted, but it's segfaulted for a different reason. It's segfaulted because I didn't give it an argument, so let's do it once more. This is the argument, run from the beginning, then do the set, and then do continue, and then we can put something here, and it's still segfaulted on the malloc. Yeah, so even if it wouldn't segfault now, and this would call the win function, we couldn't read the flag, because the moment you attach, or rather, the moment you start something with a debugger, all the SUID or SJID bits on the binary are like evaporate. So the binary is under the debugger fully run under our user and our group, and it's not run under the one which we needed to run. We cannot use a debugger for it to run with proper privileges. All the privileges have been taken away, so yeah, we cannot do any shenanigans like that. That being said, I was on at least one CTF finals where the machine was misconfigured for some reason, and you could actually just like attach a debugger without losing the privileges. And yeah, that was in 2006 or 7, something like that. So that was ages ago, or 5 even, 2005. Okay. Cool. So the one thing I'm wondering, and I do not understand currently, is does this matter? Like, but we copy something to first, because we can just overwrite it later, right? So why does it matter? By the way, gets will read anything, including 0 null bytes, until it reaches the end of line. So gets happily accepts new lines, 0 bytes, which is fine with us. Okay. Yeah, I do not get why they are doing this at all. Okay, so you know what? I'm going to do one thing. I'm going to run this a couple of times. Okay, as you can see, the address changes, which is going to be a bit annoying for us. Is it going to be super annoying for us? No, it might not be super annoying for us, but yeah. Does it change under GDB? It might not change under GDB. So let's just run. Run. Yes. Run. Yeah, it does change under GDB, which is a good sign because we want it to change under GDB. Because GDB does disable some forms of randomization. Like for example, I'm pretty sure the stack is going to be always on the same position right now, and the binary would be loaded at the... no, sorry, the stack will not be, but the binary would be loaded at the same position. But this binary is being loaded on the same position anyway, so we do not care about it. We do want GDB to not trick us into thinking we have a solution, while when we run without the debugger, it suddenly turns, hey, this one little element is actually random. So we want it to be as random as possible under GDB. And this is fine, this is actually good. Now, what we are going to do, I am going to run it with ASDF because I do not understand yet why would it matter otherwise. I'm pretty sure this ASDF is going to be overwritten later anyway, so let's do it like this maybe. I'm going to do a break on, where are we going to do a break? Let's look at the source code. I'm going to do a break on gets maybe? Or maybe on puts? Yeah, let's do it on gets, because I want to check what's in memory under the pointer which they give us. So we are going to break on, and also I need to check if one of these mallocs doesn't actually return. Yeah, if one of these mallocs doesn't return a value which actually would be in the place of the first buffer. I would prefer it not to be, but if it is, we still should be able to salvage. Okay, so let's just break on gets. Break gets, run ASDF. Yeah, run it, and now we need to check what is there. So x, I don't know, 16x maybe, and the address, we can put the address like this, like GDB will just translate it. So what we have here, it seems there are some pointers, there are 2 pointers, and both pointers are pointing, this looks like an address inside the binary. Why are there like addresses here inside the binary? Because this is the BSS section. Okay, so that's weird, but okay, that's fine. And now what we are, I'm not going to do anything with gets, or rather I am going to, I think, replicate these addresses so the application does not crash, but I'm going to make a break on the next malloc. So I'm going to do a break on malloc, and now I'm going to continue, and, or actually, you know what? Probably puts or gets called the malloc, so we ignore it, we just continue. I'm going to actually overwrite it with 4 A's, 4 B's, 4 C's, and 4 D's. And then we break with malloc, then we do return to return from the function, make cycle, yes. And then we want to see what address did malloc return, so info EAX, because EAX is where the return value is at info reg EAX, or actually like IR EAX is a little bit faster. I do not need the percentage sign. Yeah, as you can see, it's actually the same address. So this is this address is what has been returned, which you can barely see here. But that's good. That's good. That means that the allocation takes place exactly where we have overwritten these. These are probably 2 pointers. Probably-ish. So let's take a look what is in... okay, so no, wait, this is bad. What's in memory there right now? I think it's bad. Okay, our values are still here, but they were not used in any way, which is annoying. I think what we'll have to do is we'll have to... it's annoying because it means it didn't use these values in any way. Or that these values need to be some kind of special values, which I totally butchered. Let's do continue, and it continued and it exited the process, which is okay. Cool. So let's do it again. I already have a break on malloc. So let's run it with ASDF. And we are like somewhere, we didn't even reach main yet. Command reach main, okay. So this was the first malloc, I'm not even sure if it's the second malloc. Third malloc, fourth malloc, okay. And now we are in a break and gets, perfect. So now we can take a look at the structure in memory. We can just print the first, oh, we do not have a symbol table. Now this is annoying. In that case, you know what, let me think. Okay, let's see it like this. X, let's see what we can overwrite. 256 from this address, X is 200, yeah. Okay, so this is our buffer, which we control, and we can overwrite stuff from here. Not only here, but from here. Then our buffer is 256, which means here another buffer starts, which is what? We do not know which buffer it is. Okay, so we have to do, let's do it like this. Let's restart basically. We want to break in main, we want to run here, and now we want to break malloc, and we want to break gets. So we continue, and we return with the first malloc, and we get the... We are back in the main, which is fine, and so we want to know the EAX value. So this is going to be the first buffer, which is weird. That's a weird value. Well, why is it? Why does malloc has no business returning a value on the stack? That's weird. I'm just going to write it though. And we continue. We get another malloc. So we do this. This is we do not care about this value. We just continue. Okay, that was super weird. Probably. I'm blaming GDB, but GDB messed something up, which isn't unusual. Let me change my strategy in this case. I'm going to make breaks at, go to main. I'm going to make breaks after each malloc returns. So a malloc returns here. This is the first malloc. So first malloc is here. So I'm going to do break on this address, OX. Okay. I'm actually not going to do this. Then I'm going to do a break at the second malloc. The third malloc, after the third malloc, which is here. After the fourth malloc, is here. Then there are two frees, and I want to do after the next malloc. Okay. Now, I want to do, this is fine. Now I want to break after this malloc, this malloc, this malloc, and this malloc. And now I want to break at gets. Yeah, we can break at gets because why not? So let's just break here. This is breaking at gets. And then we break after the last malloc if that's possible or if it crashes. So we do OX. Okay. Now, after the break, what we want, it's command or commands? Commands, okay. We want to info reg EAX and then to end. If you do like this commands after a break, it will basically execute this command and yeah, we can do continue here as well. And we want to copy this after all the breakpoints. I'm guessing you can, oh, you can still see it a bit. So after all of these breakpoints we want it, then here we don't want it because it's gets and this is the last one. So we want it as well. Perfect. And this is the script I'm going to use, and at the end I'm going to do run ASDF. Do I need to do something else, like break main. No, I do not believe I need to do something. Oh, I do need to do break main here. Break main and RISDF. I need to first start it. So I'm going to just copy it. I'm going to restart my GDB session. I'm going to do this. And okay, and I'm going to do continue. Okay, so now we have the output, and the output is we get the first value. This is the first malloc. This is the second malloc. This is the third malloc, fourth malloc, fifth malloc, and we are at gets right now. We just broke at gets, or before gets. How is it? Yeah, we broke at gets. We are just before gets right now, so we can inspect the memory. So what can we tell about these values? Well, first of all, so this is the first one is at this address, the second one is at this address. What I'm trying to do right now is I want to reason about what's where in memory. That's basically what I want to do. This address, and then this address. And there were like 1, 2, 3 mallocs. Then there are 2 threes, and then there are 2 threes here. 3 and 3. Okay, so this is the first. And the first goes, it's like 100 byte hexadecimal, so it spawns until this address. Like I'm just added like 1 here, like 100. Then this is the second one. And the second one is being like the same thing, I'm just adding 100 because all the mallocs here are of the value 100, right? You can see here, push 100. So that's 256. This is the third one. And the third one goes until 7, and this is the fourth one. So the fourth one goes until, this is 8 here. Now, this is quite easy because this is the address which is the first address after the buffer. There are some 8 bytes here on the address. On this address, there are like 8 unknown bytes, which we have no idea about. This is the same here because, you know, it's like 618, and then this buffer starts at 620, which means there are like 8 bytes in between. If you're thinking there are 2 bytes, that means you're thinking decimal. You have to think about this hexadecimally, so it's like 18, 19, 1A, 1B, 1C, and so on, and you get actually 8, because 8 is like a middle of a hexadecimal of 10. Yeah, it's 8 is the middle of 10. It's not 5 in hexadecimal. I'm not sure if I'm making sense, but there we are. Here is the same. Like we have 8 unknown bytes. It's easier to see here between 720 and 728. We have 8 unknown bytes here. And in case here, we have like, this is 108. We have what? We have 410. And this is hexadecimal. This is over a kilobyte. Unknown bytes. So this is, yeah. So this is the memory layout. Then we are getting 2 frees, and the free, what's being freed? Let's look at the source code again. The first one is being freed, so this one is getting freed. And then we get the third one freed, so this is the third one freed. And then when we allocate here 128, 128 is the middle, so that's like 80 hexadecimal. This is the 5th buffer, 5th. And the 5th buffer actually goes here. As I predicted, okay, I gave several options, but this is one of several options that it goes here. So this is where the 5th buffer actually is going. So freed, and then this is like 5th. But the 5th buffer ends early. And now my question is, where will this malloc try to put its own buffer, which is quite interesting actually for us. So I'm going to continue. I'm going to put absolutely nothing in gets, just press enter. And then it exits, but just before exiting, it gave me this, which means, yeah, it puts it on the here, which is like the 7th buffer. What happened to the 6th buffer? Is there a 6th? No, the 6th, nothing happens with the 6th. Cool. So I'm really curious now, what are these 8 bytes? Are these like the header of the next block? Should we overwrite it? What's after our buffer? Should we overwrite it? I'm pretty sure even if we like restart the application, and even if like all the addresses will change, the locations in between them will stay the same, like the offset in memory will stay the same. So currently we have like this, then there's a break, then there's a second buffer, almost immediately after it is the next buffer, the third buffer, and the fourth buffer. And even if it's somewhere different in memory when we restart it, like for example here, still the distancing should remain the same. So this stuff should remain the same, and this is what we are operating on. And we know that this gets freed, we know that this gets freed, and we know that the 5th buffer is being allocated here, and we know that the 7th buffer is being allocated here, starting from this position for 256 bytes. This is what we know. And yeah, this is the Afterlife challenge. Okay, so if we know that, we can verify it by doing basically it again. So we exit, we run it again, and we just copy the script. And at the end of the script, we need a C to continue. Okay, and continue, enter, and it exited. It was actually kind enough to just randomize this part, but leave the rest alone. So yeah, we only, we can like, if we ignore this part, all the other digits are going to be the same. So it's 008, then 518, 260, 728, and then 620 again. And for the last one is, oh yeah, so it's the same layout, exactly for the same layout, it's just in random places in memory. Now, what could happen, and often sadly happens on CTFs, is that we will get, without the debugger attached, we will get different values, and the layout might be a bit different, but let's just hope that's not the case. Cool, so now is the question. What can we overwrite to actually crash this a bit, to like crash the party? Now what I'm going to do is I'm going to do something nasty. I'm going to do a run here, run with some whatever parameter, doesn't matter. Now I'm going to put here A, but this A letter will be, how many times? It will be, whatever is the difference, 2 kilobytes. I will put 2 kilobytes of A's, because that will give me knowledge if I'm going to overwrite anything funny, because then it will crash. And 2 kilobytes will not exceed the limit of the page, because the limit of the page is here at FFF. Obviously the address might be different. Let's actually see what the address is. We can take this address, we can then do Python, hex, and this we get, yeah. No, the ending is still the same, which is fine. It always puts it at the, it probably always puts it after, just after the libc. This is one of the older default behaviors of malloc, but it will allocate the first blocks just after, in memory, just after the C library. There are like reasons, because it uses brk function, which blah 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 blah, but let's not go there right now. Cool, so I'm going to, somehow I need to generate 2000, oh, I can do just alt 2048A, and here we go. This is 2 kilobytes of letter A. I'm going to copy it for later use, and I'm going to put it here and enter, and it should crash. And it crashed, which is good, and it crashed in malloc. So we can now check, what did it try to do that it crashed? First of all, we need to know where, in which registers, Set height 0 so it doesn't annoy me. Set height 0 basically removes this message. It doesn't stop printing out. Anyway, in which registers are the controlled values at the moment of crash in malloc? And we have EAX and EDX. These are the controlled registers, which I'm going to node. And by the way, if you talk to someone smarter than me in terms of heap exploitation, they might tell you, oh, you need to use this technique or that technique. This is true, and they might be absolutely right. As I mentioned, I actually am not the best. I suck at heap exploitation, which means I'm winging it. I know how computers work, and this should be enough to exploit this challenge without knowing exactly how heap works. I kind of know how heap works. I do not know the techniques for exploiting heap though. So that's why I'm going basically step by step to figure out what I have to do. Okay, so these are the registers which I control. Now, which instructions did we crash on? And to do that, we do x1 instruction, so that 1i on the EIP register side. And this is set disassembly, set disassembly variable Intel because I do prefer this notation. Here we go. Yeah, as you know, this is AT&T notation. I do prefer this notation, so we are crashing at this line. What's going on here? The code, whatever the code does, I do not care what the code does. I'm not going to go there. I will try not to go there. The code takes the value in EAX, which is this one, and then this is the right what were condition, because we control this, and yeah, so that's perfect. So what I'm going to do now is I'm going to actually try to figure out which bytes do I control. And to do that, I'm going to use a little bit more advanced method than this thing. And that's going to require a Python script. So this is the first Python script, well, not really the first, but some Python script of the day. I'm going to call it ASDF, because why not? And what it's going to do is it's going to output a specific pattern which will allow me to recognize which place in the A stream, or actually input stream, are the things which which are put in the register. And this is going to be trivial. So what I need to do is basically, I have how many? I have, so how many is usually denoted as n? N is 248, because why not, but divided by 4, because I'm going to use 4-byte values. Now I need import struct dev dd value return struct pack. Okay, this is like, I give it a value and it returns me like an integer, and it returns me 4 bytes, little endian packed, like this value as expressed as little endian noted in 4 bytes. Is it little endian? This is little endian, otherwise it was big endian. Okay. It's easy to figure out because this triangle brackets, like the small part is pointing to the left, and the large part, so larger numbers on the right, smaller numbers on the left, that's little endian, basically. Cool. And now we do the pattern, so we do for I in range n, we do, let's just do some output here. Okay, this doesn't have to be passed, whatever. We do dd, and we get some value, which is for 1, for 1, for 1, for 1, and we append I to it. And this we do append to O, and then we print O. And this isn't going to be the greatest, but it should work. I'm thinking about what will exactly happen here. So this is what, 512, right? 512 times, no, yes, 512 times 4 is 4098. So this will overlap, yeah, this isn't the greatest pattern. I need to kinda change it, because otherwise it will, at one point, reach a sign which is like 41, 41, 42, OA, And this OA, this is a line ending, and it will break gets, it will stop gets, and anything which is after this will not be copied. So no, I cannot do this pattern, that would be too easy. How many bits is this? This is 9 bits. 9 bits, which isn't the greatest, but okay. So if it's 9 bits, I can just split it into pairs of 3 bits, 4 bits. 4 bits and 5 bits. 4 bits is between 0 and 16, 5 bits and 32. So that's 60. Okay, that's perfect. Okay, so I'm going to do basically is like higher part, it's or like lower part is going to be I, only the lowest 4 bits of I. Then a higher part is I moved by 4 bits, and that's it basically. And here what I'm going to do is I'm going to do this value or lower bits, and the lower bits will basically be I need to change this. Yeah, lower bits will be put here, like the L will be put here. And I want to do the same with H. H is 5 bits, which is fine. It's fine because it will switch it to 50. But to do this trick, I need to move H by, what is this position? Is this position is 8? Yeah, I need to move it by 8 bits. Okay, and this pattern now I can decode later on, and it should be printable if I didn't mess anything up. Python, which Python am I using? I am using Python 3 because I said I'm switching, so Python 3 ASDF UI and float blah blah, because this, okay. And only concatenate strings, not bytes. Why am I using Python 3? Why am I doing this to myself? Yeah, that's fine, whatever, just do it. Okay, this is fine. This shouldn't pose any problems. I can just do encode here to UTF. Encode ASCII, because it doesn't matter. It should be all printable anyway. Bytes have no, because okay, here we go. Okay, so this is the pattern which I'm going to use. It's a nice pattern. I like it. I'm going to put it in my notes. Is this the end of the notes? Or did I, what happened to my AAs? Never mind. Okay, cool. So, yeah. Do this, run it with ASDF, put the pattern in, did it seq at the same address? Yes, it did, but 97DA, perfect. So now I want to print the registers, and we have the following values in the register. 0, 0, 0. Oh, this is getting interesting. This is absolutely interesting because these are the values which we already tried. Did I mess something up with my code? Are you saying? No. Okay. Because these are the first 2 values, right? This is like this value, and this is the next value here, which are the values which I thought we already tried, but where am I doing something wrong? Where are the low and no? This is correct. Is the pattern fine? The pattern looks fine. So this is weird, but like whatever, that's fine. Like okay, it can be weird. I do not care as long as I'm still able to do something with this. So what I'm going to change here is I'm going to actually make a a list out of this. So we now have a list of DDs, and therefore in the given pattern, which is like I know is 0, right? I can, you know what? I'm going to actually make myself a favor, and I'm going to create a function to index, and it's going to take the pattern, like for example this value. So it's going to be like okay, let's go to V. And I'm going to grab from V, I'm going to do the reverse of this basically. So I'm going to grab from V the lowest 4 bits, and I'm going from V to move V 8 times, and I'm going to from there grab the lowest 5 bits, which is this 1F. 1F because 1F is like 1, 1, 1, 1, 1. Yeah, so that's like lowest 5 bits, right? And then I'm going to return L or H moved by 4. So I'm going to do the reverse of this. And thanks to this, I do not need to print the pattern at this moment. I can actually verify that to index of this value, what's the index, what's the position actually. I'm pretty sure that's 0 and 1, like it's obvious, but I'm doing this for myself in the future where we might start getting different values, much weirder values. Okay, yeah, 0 and 1. So now I can change in this index. So yeah, now based on the pattern, I'm getting the index and I can put any other value here. What other values do I want to put here? I want to put, well, this is the right what where, right? So which value is in which index? 0 is an EAX and EAX is this. So I need to put the address of my, let me copy this a little lower. So this is the win function, this is a what, and this is the where. And the what and the where. The what goes into EDX. So this is the what. I can just put it straight up here. Like this. This is the win function address. And the where is this. And this is the got.plt exit address, function address, whatever, function address. Okay, so we are putting the where here, sorry, what was the what, obviously. The what we are putting here, and the where, because it's the right what where, we are putting here, but there is this plus thingy here, so we need to actually we need to subtract it, so then when it's added, we still get the same value. And now we can print it, and to print it, we need to do a join, and to do a join, we just do a join. Yeah. And now we get a pattern. ASCII cannot decode, but we get the weird pattern. Why am I doing this to myself? I really should like... Okay, do this and do it, just do me, like, yeah, just print it like this, whatever. Okay, this is a space, then we have some weird values, which is fine. Do I have Python here? Because what I need to do, tell me I have Python. I do have Python, this is amazing. So, okay, cool. So I'm grabbing this thing. Where can I write a file? Can I write a file in TMP? No. Can I write a file in my home directory? What's my home directory anyway? That didn't help me too much. Yeah, I'm like thinking now, how do I... Yeah, this is home Genvale, okay, that's easy. So in home Genvale I can probably create a file. So Python, and you know what, this is actually, no, I do not have to use Python at all. It's enough if I use echo-en, actually without the n, then the value, and then home Genvale evil. Okay. Now, ls, if everything went fine, the size of this file should be 2048. And it's 2049. Okay, 2049 is fine because there's the end, like end of line at the end. So that's fine. Perfect. Now let's go back to GDB. gdb, perfect. And what do? We do this and we redirect evil to it and we get a malloc, and the malloc broke at a different address right now, which is expected because, as I said, like it's going to do two moves, not only one move. What we can check, I guess, is if it actually worked. So the where, what is the where? We can see what's the value under the where. And to do that, we do x1x on the address, on this address. And we have the what here, so it did work. Now we need to stop it from crashing. And as soon as we stop it from crashing, we get the flag. As long as it works outside of a debugger, which isn't guaranteed. But let's hope for the best, right? And just carry on. Cool, so we have a crash here now, and we have to figure out what kind of crash this is. And to do that, we do the standard. What registers do we control? We control no registers, which is worrying. This is really worrying. Okay, so because the GOT address is probably not. It probably tries to write to this address. Please tell me this is the case. This is going to be annoying. But yeah, x1 instruction from the EIP address, and this is this assembly flavor Intel. Thank you. Yeah. So this is It just writes. It's a different write, and it. So this is a controlled value, and this is both. These are the controlled values, right? No, this is to C. Yeah, these are both. Why didn't subtract or whatever? I'm pretty sure these are the controlled values because these are our values, right? From the really close to this and really close to this. Okay, so what do we do about this? It crashed because it tried writing to EAX, to this address, and this address is not writable. Let's check it in IDA. Wait, what is this address? This is the address of the, this is the address of the win function. So this means we cannot really put anything in the win function. Like we cannot jump to the win function, because if we jump to the win function, it will try to write something to the address of the win function, but it cannot write something because this area of memory is not writable. There is no writable bit. It cannot write here, so it crashes. Which means we cannot call the win function directly. Here is the moment where we actually go back to this and we scroll up and we look at this. Oh, the NX is disabled, which means we can just put some code in memory and jump to that code. Where to put the, where exactly do we put the code? Well, we do have the address. We are getting the address, right, of the first buffer, so we can just put it somewhere there. Or we can calculate the address of any buffer, basically, thanks to that. And you can just put it there, and we can jump there, and then it will write around the buffer, which is fine. Because we will, in this case, we are keeping the where at the same place, because this is a writable address, this is writable. This is not writable. Yeah. So we just need to change the where. And if we change the where to an address on the heap, then it will jump to the address of the heap, and then where we have to put some code which will jump to win. It doesn't have to jump to win at that point. It can just read the flag and show it to us, but it's easier to jump to win. How are we going to write the code which is going to jump to win? Well, this is going to be super easy because we are just going to go to do this. Move EAX this. So I do not need a compiler even for this one. It's B866890408. That's B8 for you. Okay, and then jump EAX, and I do need a compiler for this one. I do not remember the opcodes for jump EAX. So this is what we have to do. Let's create the shellcode first, or the payload, whatever you want to call it. 32 bits, and yeah, this is fine. We put the address in the EAX register and we straight jump there, like no magic. We could actually do just like a push here and then a ret. This would work as well. There are like multiple ways. Actually, you know what? We are going for push and we are going for ret because this will be a little easier. Yeah. So here we do nasm b asm and is asm b32b. Yeah. And this is our shellcode. Here we go. Okay. So I push it and then we immediately return to that address. And yeah, that's pretty short as well. No weird characters here, so we just need to put this somewhere there. And this is our okay. Cool. So how do we structure this? Well, we can put it, I think, almost anywhere in memory. Okay, so we are changing the what to an unknown address. We basically have to first run it and then figure out what the what is going to be, because the what suddenly isn't this. This is like the change me to address of first. So we have to fix that. And then we can put, so these are like 0 and 1 and we know it. We can put it somewhere in a safer distance. Let's put it at like offset 20, because why not? We put the first value, which is, sorry, the first, because we need to split it into basically, yeah, well, this can be 41, this doesn't matter. This is our shellcode. We just have to pad it to 8 bytes. And what does it? Okay. So this is this. And then on 21 we do the other one. Okay. Let's just do this so we know what we have encoded here. Okay, and now we need to change this what, this what to, no, the what will be changed there, okay. But this what is actually going to be times 4, yeah, so the address of this basically. Okay. This will not work, but let's see what happens. Let's see what breaks. Okay, let's do this. Let's run it under GDB. We do run ASDF. I still don't know what the ASDF is supposed to be for. And I'm copying this value. I'm putting this value here. It can be decimal, that doesn't matter. Then I do this, and yeah, this is where I need to somehow input it, which is going to be annoying. I guess it's best if I do it from Python, so I need to actually write a proper exploit here, which is annoying, but okay, let's do a proper exploit. Okay, so how will a proper, do I have Python 3 here? I do have Python 3 here, perfect. So what I need to do is I need to import subprocess I do this, but I do this in a second. First, I'm going to create the process. So p is subprocess popen Python 3. No, okay, well, I'm sticking with Python 3. I had a moment of weakness where I wanted to go back to Python 2 because it would be so easy to do it in Python 2. But okay, let's do it like this. Popen, then the actual command which we need to run, which is going to be this path. And then it's called vuln, right? Ls, it is called vuln, so we are running vuln. Then like SDF, because yeah, whatever. And now I need to basically do standard input. I need a pipe for it. So std n is equal to subprocess pipe, and I need to do the same with standard output. We can do it the same with standard error, but I don't really care, but let's do it. Okay. Okay, so now it started the process, and we cannot use communicate. What can... with popen, wow, this is amazing. Alright, I didn't know you could use with. I'm absolutely using this with as p. Okay, perfect. So what we need to read first from the standard input is we need to read until we get the address and like this. So how many bytes is it even? So this is what? 72 characters, so that's 72. This is 10, 9. Okay, this is 9. And this is 84. 84 plus there are new lines. But it's like, it's enough if we read this. So pstdn read, we read from, yeah, we read from standard input. That's what you wanted to do, called it, right? Now we do this, and so we get lines from this. And now we need to split the lines. Split lines. Will it be, I absolutely need it to be in binary mode. I cannot have this in text mode. How do I do it? Well, maybe it's fine. Maybe I do not have to. Yeah. Okay, split lines. So now I have lines. Now in line number, what is it? Let's just run it. Vuln. This is line number 0, 1. Line number 1. In line number 1, we get the address, right? So we just, yeah, this is like the, this is our what. So we set the what to this. And now we can do all the magic which is happening here. We can have these functions actually be up front, so let's move them here. Then this magic is happening, and instead of this here, we do data is equal to this, and p standard input is going to be the data, and we need to end it with a new line character. This is something I sometimes forget. And standard input, write into standard input. So we write into the standard input of a process, and then we basically need to get the flag at the end. Like that's basically it, right? So p read 496, I don't know, while p read whatever, while true, print whatever you get, and then it will crash. Then it should crash if it stops reading because the process is dead, but maybe it will not crash, so I'm going to do d equals this. Here do d, if not d, then just break. Okay, let's see if it works locally. So what we need to do is we need to run with Python 3 ASDF. This is just to fix all the typos. Okay, no such file and directory, obviously, because this is on my local machine. It's just Vuln. Okay, doesn't. Where did you freeze? Have you frozen at reading? This is where print comes into play, or rather sys. Now we can do print ASDF. That should be fine. Didn't put ASDF. If we're here, put ASDF here. Okay. It did. Vuln SDF. Why didn't it finish reading? What does the read do anyway? This is a pipe, right? So it should just like. I can probably just use like read line by way here. I don't have to do the split lines dance. Let's do something like this. While true, p standard output. By the way, did I have here standard output? Yeah, I forgot it. Read 1 and do just print it and see what happens. So wait, did it actually work? This read is weird. No, wait, what? I'm not running the script. Okay, so it doesn't read for some reason from the process. Why doesn't it read from the process? Does the process? Yeah, the process just uses puts and. Because the process, okay, let me guess. Because the process is stupid and. Because it has buffering turned on. And if it sees a pipe, then the buffering will not output anything, so this will actually not output anything. Just a bit annoying. No, okay. You know what? Let's just go back to the old idea. I'm just going to span two shells. No, but that doesn't solve my problem. Alright, you know what I'm going to do here? I'm going to do strace -f -e trace. I need only write to be traced. And then Python 3 ASDF.py. Okay, it didn't write anything out, and now if I do just vuln, it does write. So it basically, from what I see, it doesn't flush the buffer, which is absolutely annoying. And it doesn't flush the buffer because I'm attaching a pipe. This is a normal behavior, an absolutely normal behavior. But gets should force a flush of the pipe. Why does gets not force a flush of the pipe? The way around it is to create a terminal, which is annoying. Because it's like this. When you do a print, it actually is buffered, right? And the buffering type depends on the type of device attached to the standard output. If the device attached to the standard output is a pipe, the buffering works like this. Until you have, I think, 1 kilobyte or 4 kilobyte of data, nothing will be shown. Nothing will be like the right syscall is not going to be called. And I guess we can emulate it by doing this. Yeah, as you can see, there is like, it crashes, but like nothing is printed out. Yeah, nothing is printed out here because we change the standard output from the console, which is a terminal, actually a pseudo terminal. We change it to a pipe, and suddenly the buffering is not working. So yeah, we have to create a pseudo terminal, which, yeah, as I said, is annoying. Okay, I think, yeah, let's just do that. Just like import pty, and we can do spawn and master read, master write our functions. How do we use it? Okay, we do spawn and we do a read, and read is a function which just returns data. So we do, instead of this, which is the subprocess, which I would love it to work, but it obviously does not, we do pty spawn of the same thing, but this time it's actually just this. And then it gets a function, and the function they are calling it read, I'm going to just call it like expl, because why not? And yeah. So we can put it here, and let's put it here. And then this everything here is going to be called expl. And the expl will be, let me just make sure I understand. That's master read. The function master read and standard are passed a file descriptor which they are told should read from, and they should always return a byte string in order to force. What does it? Script write data. I'm not really sure what it does, but let's see. Okay, there's a file descriptor here, and we'll have to work with that. So this goes, because expl isn't defined yet, so we have to do this. And then instead of here, we do fd read. It will probably crash in a second, but that's fine. Please tell me you actually will print out the lines. Okay, this is a funny bug. What are you doing? Let's just comment everything out. Wait, fd, wait, this is a real file descriptor? I have to do as read on it? Okay, that suits me, I don't mind, but that's funny. I expected like a file-like object, but like whatever, yeah, sure. So not this, but as read, then the file descriptor, and then the size. And then I'm not going to do split line yet. And here I'm just going to do like return whatever, like, yeah, like just do this. Ignore the rest of the function for now. I will be absolutely happy. Exit. Okay. Why? Why? Because I am calling KSDF? This is weird. Did my console just freeze? Yeah, my console just froze. It's pretty weird. Here we go again. Okay. File. In order, okay, that's fine. The default implementation, both function will read and return up to each time it's called. Yeah, that's why I said it's annoying. We have to do probably weird stuff here. So this is supposed to just return the lines I get. Python 3 SDF. Okay, why does it actually... This is what I don't get. Why does it show me like some Python errors instead of... Okay, because it's still inside. Okay, now I get it. Oh, it didn't break my terminal. That's weird. So, the spawn. What does the spawn take? It takes argv. Is the argv... Is the argv supposed to be a table? Because if it's a table, then it's fine. We can do this. Let's try it again. Yes, it works. Okay, perfect. Now we can continue our work because it does output. So yeah, this is annoying, but whatever. Like, this is CTFs. CTFs are supposed to be annoying. So we have the lines. We return lines at the end. So this is like original data, actually, org data, and the lines is the org data, which is split. And then we can print lines, and here we can return org data. I'm just going to go step by step to see what's going on. Okay, it prints me the lines, which is fine. Now print me the what. Print me the what. Okay, I'm going to move the console a bit here. What is undefined? What? Okay, so this is okay. It printed out the other stuff to my console, which I do not care about, but it also printed out this, right? Okay, yeah, it prints out, it gets correctly the address. This is all I care about. I do not care about everything else. We go here. Now the question is, how do I write to it? Can I just write to it? We'll see. So we do not do this yet, but we will have to do this in a second. Okay, so we do OSWrite into the file descriptor. The file descriptor should be both ways, and if we send something, it's sent as a keystroke, which means it's sent us to like standard, no, not as a keystroke, it's sent to standard input. I hope this works like this, because it should work like this. What I need is, because this function is going to be called several times, so I need some kind of a flag, and I hope the flag, oh, you know what I'm going to do? If has if this function has an attribute called ASDF, then just like get the data and print it, and yeah, like just do data equals as read this, print the data, and return the data, and that's it. Otherwise, we set an attribute to this function, which is called, yes, functions can have attributes, so this is basically a flag. I'm doing it like this, and I'm not doing it on with a global variable because I'm not really sure what, I could do that with just a global variable, but I'm not really sure in what context does this function run. Does it still run in the same interpreter, or does it run in the context of a different process, for all I know? So I don't know. Okay, blah 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 blah. Okay, try it. Let's see what fails, because something will fail. That's normal, that's fine. Okay, and it says that I want some debug messages though, because I have no idea where does it actually go. No, it just fails here. Expected 3, like whatever, just 1. Yeah, just type reset if that happens to your console. Can concatenate Python 3. I'm sorry. Okay, well, this works. At least it outputted something. And then it says that read takes 2 arguments. Oh yeah, and I gave 1. So here we need FD, right? Yeah. Okay, something is going on, which is fine, I guess. Okay. Now I'm not really sure what's happening, which is not okay. So what I'm going to do here is, instead of writing that nice data, I'm going to write just like ASDF, or like just write a new line. And returns. Okay, what's at the end of this program? Because I kinda would love it to. Oh, it just exits. Okay, it just does a gets and an exit, which is okay-ish, I guess. Let's do an strace. Strace of, yeah, debugging this will be a pain. Fe trace exit. And it does return, so that's fine. So what happens if I actually send the data there again? Does it actually pass the data? It's okay, it crashes. Crashing is fine. I like crashing. Crashing is fine. Cool. So this is our exploit in that case, and I'm going to move now to the remote server. And since I'm moving to the remote server, I need to do this little thing. Okay, and yeah, here's another question. Show me the source code. The source code is the win. Yeah, it opens the flag which is in the current directory, which means we need to stay here. So I need to do home gunveil like asdf.py. Just put it there. Python 3 home gunveil asdf. And it did something. I have no idea what it did actually. Yeah, I'm not sure what it did exit though, right? So what exit code did it have? It had an exit code of 0, so it did exit. Did it work? It obviously did not, because I cannot see the flag. I should see the flag if it would work. What do we do now? It's a nice question. I think I can get rid of most of this output actually. So let's do okay. Let's make this a little bit shorter. I think it's enough if I have what? So n is equal to 22 times 4. Yeah, this should be fine, and it will be a little less clutter on the screen. Okay, so I'm going to add some test messages basically. What I need to do is I need to first here on the split lines, I want it to print, not on the split line, here. Okay, and we get the what. Okay, what found? So it correctly interprets it. Then okay, then the question is like, am I actually printing this? So I'm going to disable this for a second, and I'm going to disable this, and I'm going to check if it crashes, because now it's just the pattern, right? Please crash. Oh, but I'm getting the error code of my, so I don't know if it crashes. This is going to be annoying. What I need actually from it is a core dump, because having a core dump, oh, but it's not going to dump a core for me. Can I somehow attach a GDB to it? Oh well. Okay, so here's I'm thinking of a backup plan. I think I can do an S-trace still of it, which is nice. S-trace dash F dash E trace write, because I want to know, or read, because I want to know if the child process is receiving my pattern. So yeah, this is nice because we see it. This is messy. Okay, we do a read, we read this is our process reading, this is the Python process, right? S-trace, okay, this is running, okay. Okay. What found? Read resumed. So read from this process is reading this, but it's not the process I wanted to be reading. This process is zigzagging. I think it's fine. It's good, but it actually like just zigzags. I liked that it actually crashes. What I need to do is I need to store the log somewhere so I can read it like in a second. Home, ginveil, xyz, and now let's home, ginveil, xyz. Okay, let's see what's going on here. So I'm creating a process, right? And the process is reading this. Which process is reading this? This is my process, so yeah, okay, this process is reading. This is fine. This is like the good process, which is supposed to be reading it. At least I think so. And then it crashes. So this is good. Okay, so that's good. Now, now I can actually like do vim. I can uncomment this, so it actually writes stuff and it jumps into bogus data. So yeah, strace and run it again, and now read the log. Okay, and it's zigzagged again, which doesn't bring any information to me, and I needed to bring some information to me. How to bring some information to me? I can actually override the memory with 2 writable address so it doesn't crash, and that will tell me quite a lot. So to do that, I'm actually going to disable this, and I'm going to disable this pattern generation in order to append dd and give it only writable addresses. So I know that the writable memory is at what, so I just give it what. Yeah. And now it should not crash. This is weird stuff on the screen, but that's fine. Let's see the logs. Sorry about that. Yeah, the logs, okay, it didn't crash. So this is information. We know it didn't crash now because it had writable memory. Now I'm going to change it with some memory which is not writable, and I'm going to see if it crashes then. Because I think we are nearing a solution. We can kind of debug it right now. Well, not really debug it, but we can reason based on crashes or lack of crashes. So instead I'm going to put the address of the win function, which is not writable. And the address of the win function is not writable, so it will crash, right? So this is the address. And here we go. Strace, blah, blah, blah. Then see the logs. And what's pretty interesting, what's going on here, whatever. Yeah, it crashes with a zigzag. It crashed, there's some info. And this is perfect. And it crashed at this address. What is this address? This is a weird address. Is this the address of one of the Where are my notes? I'm looking at the three last bit, like nibbles, three last digits. That's 972, and is 972 related to any of these addresses? It's not. But that might be like signal information address. Can actually ptrace show detailed, not ptrace, strace signal like sig seg info. Okay, but can it actually give me that detailed signal information? Let's trace. Okay. Okay, options. Are there any signal related options? strace is like super powerful tool. If you look through it, it has like a lot of super interesting stuff. Okay, nothing obvious, so I can just continue blind, I guess. Cool. So now let's see if I'm getting everything right, because I do not think I'm getting everything right. So let's go here. Let's make the pattern again. So it will crash now. Now I'm going to uncomment this, which will make it not crash. And here, the where and the what. Okay. And this puts my code, and my code is this. Now I'm going to actually change my code to another pattern. And the pattern is going to be EBFE. Is that correct? That's correct. And then 2 zeros. Well, maybe not zeros. Maybe let's just do this pattern twice. EBFE is an infinite loop. So if it works, the program will freeze. And we'll try to force it to make the application freeze. When the application freezes, we know we have code execution. And this is just a couple of like steps from our exploit being ready. Cool, let's do the trace. It did not crash. Well, it did not hang, which is sad. Because I would love it to... Please just crash. Yeah, this is basically what I'm trying to tell it. Please just crash. Now this 20 is here. It's fine. Actually, just tell me how much data do you have here. Run data. Okay, so tell me that. We are getting 220, that's fine. Let's see if we can actually, if it changes anything, if we do the full pattern range. Where do I do the full pattern range? I do it here. Okay. There is a lot more stuff on the console, but that's fine. We still get 6 seg, that's fine. Now I don't really know at which where does it actually 6 seg. The problem might be that there might be some more, like another, yeah, there might be another place in malloc where it actually 6 segs. So what I could do is I could put some neutral addresses, and yeah, I'm going to copy my sdf.py as xyz. Here we go, and I'm going to get rid of everything which is not related to the pattern. So I'm going to just get rid of this. And I'm going to do this, and I'm going to get rid of this because I want to generate another pattern. And the pattern I want to generate is I want here to put an address which is writable in memory. And to find that address, I'm just going to go to the BSS section, I guess, this is the BSS section. I'm going to choose a nice address, which is this one. Is this a nice address? Yeah, it's absolutely phenomenal. I am going to go with this address, and therefore I'm going to, yeah, because I want to see if malloc crashes any place else apart from, does it use any other stuff apart from these? Because if it does, then we can do something about it, but we have to go back one step basically. And here what we need to do is we just print data. This is not needed, this is not needed, this is what we can actually delete. And here is the shell, here is no shell. XYZ, lines, okay. The what doesn't matter, like, are these 8? Yeah, it's 8. Okay, perfect. So now we can do, let me just grab this, and we can do echo home ginvale t echo dash e to escape, and then what? This is the pattern, and we put it in ginvale t, and now we can use the debugger again with this pattern, which is great, which is absolutely amazing because we need to use the debugger for this. So we do this, we do then we run with ASDF and this, and does it crash? No, it exits normally, it doesn't crash anyplace else. Is it good or is it bad? It's weird. So what I'm going to do is I'm going to do a break at the exit. Run ASDF with this, then it breaks at the exit, and now I can see what did it actually write somewhere in near this memory, like not at the exact address, but somewhere there. So this x20x and the address, and there's some. Oh, that's weird. Do I need another address, or did it? Well, whatever. Yeah, that's pretty weird, but okay, that might be fine. Now what I'm going to do, I guess, is I'm going to try the same. Maybe I can just write my shellcode somewhere else. Well, doesn't matter. Okay, what I'm going to do is I'm going to look for UD2. UD2. I do not remember UD2. UD2 is OFOB. Okay, OFOB. OFOB is fine. So I'm going to try get code execution with to go basically to OFOB, because this is UD2, and UD2 will give us sig eel, like a different kind of signal when it crashes. So with strace we can actually see that something is working. So then, okay, now I'm going to change the pattern, absolutely remove this, and instead I'm going to append, yeah, you guessed it, I'm going to append bx x, and then I'm going to repeat it, ob. Okay, so now I'm doing this, and then I'm not doing this, I'm just putting this everywhere in memory. So if it crashes with illegal instruction, I know I have code execution just at like different addresses than I expected, which is fine. Cool. Now I can quit, I can do an strace. And now I can do a less. And my less is 6 segving. It's not, yeah, it's not, this is a little bit annoying. I can do one more thing actually here. Now you know what? I'm going to attempt to use the same pattern with these addresses, but so cat. Okay, let's grab the same pattern. I'm not sure if like one of these bytes doesn't break my pattern actually. That's what I want to test right now. So do this. Okay. I just copied it in a... Okay, and now I'm going to put it here with echo-e this to home ginveil k. And now I can use the debugger to see what's up. So gdb vuln break on exit, break on, well, don't break actually anywhere else. ISDF this. Okay, then we broke at exit. Now my question is, what's in memory? That's my first question. And yeah, the memory is fine. Now I'm going to interpret the memory as a series of instructions. And UD2 is there, so this should actually kill... yeah, if we jump there, it should just like be sig-ill. So yeah, we can just check it, like if we do call and this... that hardly worked as expected. Set EIP to this address. Did we exit? We didn't exit yet. Why does it? Okay. And we do continue. Yeah, it does sig-ill on this address. So that works. Why did I check it? Because some virtual machines might act weird with some instructions, and for example, UD2 might not actually generate sig-ill, but it does, so that's fine. Now what I else want to check is, I think I'm going to change actually the BBS address which I'm using. Let me go to data section, actually to the end of the BBS section. So let's go to the end of BBS section. Where is the end of it? Because we're, okay. Well, whatever. This address is fine. So this is fine. Because that means that this actually goes into memory, which is good. And it behaves like I want it to behave, which is also good. The next thing I need to do in that case is to... Oh, wait, because I'm still writing it here. So, okay, what I would love to do now is I would like to make it not crash. And to make it not crash, I'm going to put this address, and actually I'm going to add something to this address. Like, let's put here D950, that sounds good. Okay, so O of 0, we put this address there. And O of 1, we put this address there, and I would love it to not crash now. GDB vuln, no, strace. Okay, less. And it still crashes. Why does it still crash? It should not crash now. It should have like, it should just be able to write to that memory. Let me look at the addresses again, maybe I did. No, BBS is on this page. So if I go up, this page still exists here. So this is fine. Does it still exist here? Yes, this is still the same page. This is like 0804D, which is okay. And this is a writable page, so this should not crash now. Why does it crash? Am I looking at the correct logs? Which is a good question to ask. Yeah, I am looking at the correct logs. Because it should write something to something there. Okay, let's make it not crash because it's weird that it crashes. If I do not like, let's put a different pattern here. Let's put a pattern of append. Actually, like the same pattern which I have there. So 804 D950 DDA, obviously. So I want to put the same pattern there, and let's see what happens. I hope my pattern actually arrives correctly, because there might be some weird stuff going on with the pattern. Especially if like there's some UTF-8 encoding or something, which I hope there isn't. Okay, 6seg, still 6seg. What about... what if we make it shorter? Let's make the pattern shorter and see if this is still 6segving us. So we run it. Yeah, it's shorter, visibly shorter, right? Now we do less, and we see it's still zigzagging. What do we have to do to stop it from zigzagging? Because this is weird now. Here, just write like, instead of data, just write a new line. Please stop zigzagging. Then less. Okay. Now it did not zigzag, which is good. Now, what if we put here zeros? Like, let's just put here zeros and overwrite anything else. But the anything else is actually going to be short. I'm going to go with n equals 8. So it doesn't actually overwrite too much, and I'm just going to... Actually, I'm just going to write zeros everywhere. So append td 0. And it's still 6x because no, but why are you zigzagging? What am I overwriting? Okay, let's make. Okay, I need to basically figure out how does it behave without the debugger, because there seems to be some difference in how does it behave without the debugger. So I'm going to go with the shortest pattern possible, which is 4, which isn't even a pattern, right? And I could do this now. When I do less, and it still crashes. What if I... Why does it crash though? What if I just override 1 byte? Like, it shouldn't crash if I overwrite it with 0. So let me overwrite it with something else. I'm going to overwrite it with this address above, which is that's a nice address. It should just work fine with it. Maybe it doesn't like the D4 here, but yeah, like, deal with it. Okay, it still is zigzagging. So the gets is also overwriting 1 more byte at the end, but that should not be the problem. Let's not do anything here now with this pattern. Instead of generating and writing this pattern, what I am going to do is I'm going to do... Okay, so if I just write a new line, there's a 0 byte written at the end. And this is not zigzagging, right? This is not zigzagging. I'm going to send 1 byte, which is going to be A, and S trace, and less, and it already zigzags. Okay, that's kind of okay. Now I'm going to send actually a different byte, and the different byte is going to be, I don't know, I'm going to send 0. Let's see what happens. strace less zigzag. Okay, let me try with okay, because I'm overwriting. What address did we see there in the debugger? So let's run the debugger. GDB vuln break on exit and run, and I want to see what values are here. Wait, run ASDF. Yes, then I'm just doing enter, and I want to see what's here. Cannot access. Wait, what? Why cannot I access this memory? That's weird. Okay. Maybe exit is too late. Let's do break. Gets not malloc puts. What's at the end? There's gets and then malloc and then exit. Like, why doesn't? That's weird. Let's do it again. I don't know. Maybe that's a. Okay. Do this, and I'm still here, right? Yes, I'm still here, so it shouldn't have executed anything yet. Cool. Okay, now it exists. So this is what we did overwrite with the 0 by just doing an enter and gets, and here this is some weird address. So I'm going to overwrite whatever. I'm going to make a pattern rather with 2 of these. I'm going to do a pattern, sorry, this is 4, with 2 of these addresses. This should not crash the application. If this crashes the applications, I am absolutely confused. Strace less jump to end, and it crashes. Why? Why does it crash the application? Which application crashes? This is weird enough, but I want to do something more. I want to put here with open home gunveil ttt write binary as f write the data there, and also include a new line. Okay, do this, run it again, it does whatever. And now I can basically replay it from the console. So I do vuln, and I do the home gunveil ttt, I send it there. And it also segfolds, which is good, because that means that at least this is... I don't understand why it segfolds though. Are we overwriting something which is next in memory? Should this pattern be a little bit longer? If we scroll up, in memory there are just zeros, so we overwrite this with 0. I would love to see the core. I don't believe I would get the core in my home directory, right? That would be too good. I would love to see the core though, but I'm not going to see the core. And maybe with strace I could see the core. But I can see the core with GDB. I can take a look in GDB what's going on, which is fine. So this home gunveil ttt, okay. And process exited normally. Why are you doing this to me? It behaves totally different under a debugger. Does it? Yeah, and it 6 seconds before we actually get a code execution, which is also annoying, because we don't want it to 6 seconds before we get code execution. Under GDB, I think malloc changes a little bit its behavior, and this is what is what is annoying us here. ASLR is disabled, so it is pretty weird. How does okay? GDB malloc behavior. Does it actually change? Okay, hooks for malloc. GDB, I don't know, I know that's not related to GDB. Huh. Okay, can I exploit it blindly somehow? The problem is that even if I give it some pointers, the pointers still crash it. So another thing I can test is I can just make, like, flood it with a pointer which is what? Which is like, I know is writable. So if I do actually, if I do this n again, and I actually put what everywhere, so I do what here, I know everything is writable now. And if I put the data here and I write it, let's see if how this works. So I do this, and then I do less. Okay, and it didn't crash. Okay, this is getting somewhere. That's fine. That's cool, but it didn't crash. I like that it didn't crash. Because if it didn't crash, we can try to override some part of it. So what I'm going to override is I'm going to override this where with it. The where, I hope this binary isn't like all over the place, like, okay, no, it should be fine. So I'm going to do this. And let's see if this crashes. Trace, now last, let's go. Okay, it did 6seg. So it crashes when writing to the GOT table. Okay, so what happens if we actually do the other write? We override the second pointer with something. Might crash, it shouldn't crash actually. Okay, it didn't crash. So yeah, this is fine-ish. Because we seem to have a write, we seem to be able to write somewhere, but we are not able to write where we want to write in the GOT table for some reason. Or maybe we can write there, but it crashes on the next step. It crashes when it actually gets to the code which is supposed to. Okay, so you know what? I'm going to jump somewhere else. I'm going to, no, I cannot jump anywhere in here. So what about if we, this is wrong code. What about if we do the pattern with EBFE again without some places? So I'm currently putting what here. What if we start like, this isn't crashing, right? So what if we put this EBFE in several places? So I'm going to put it at 20 and I'm going to see if it actually crashes. Trace less G, which it did not. Cool, this is good. So I'm going to put it now in multiple other places. I'm going to, let's say, put it from here to 40. No, this is, I'm just making myself a disfavor right now. Let's do it in a loop. OX20, OX40. So just do it like this. Okay, and I'm trying to put infinite loops, EBFE, in multiple places in memory as long as I don't crash it. So it's still not crashing. So I'm going to extend this to 400, because why not? Trace, and it said it complains about something. 400 is too much because you have 100. Let's do it 100. 100 will be enough for us. Less. Okay, and go to the end, and it still didn't crash, so that's fine. So now we have in memory a lot of infinite loops, which is good. And the next step is going to try to override again this where, but I'm going to change the what a bit from time to time. So now it's 20, it's what plus 20 plus 4. Sorry. I'm going to leave it now and see if it crashes. It should crash, okay. And now I'm going to play with the value a bit. I'm going to put here 30 and see what happens. Wait, am I doing it correct? Yes, I'm doing it correct. Okay, it still crashes. Let's get 40 here. Okay. 50 maybe. No, still crashes. Okay, so I do expect we are not getting code execution. That's the problem. I'm going to first do less. It crashes, and now I'm going to run it, and it should not crash now. And it does not crash, which is fine. Okay. The where. Is there a problem with the where, with overwriting the where? We can overwrite something else in that case. What are we going to overwrite? In all honesty, if we had time, we could just brute force some address in memory, but yeah, that might take too long, so let's not go there. Instead, I'm going to put here, actually, under this index, I'm going to put what to see if it doesn't crash. It should not crash now if I put what here. And it does not crash, which is good. I see you say on the line says on the chat, you can't believe how gratifying this is. On my last 3 CTFs, I completely failed binary exploitation, Charles harder than buffer overflow. 3 times exploit worked under GDB, 3 times failed on target. But yeah, this is pretty typical. Like this is what you're seeing here. This is a real CTF. This is not like easy challenges which you just rush through. This is how exploiting on real CTF looks like. It is a little bit harder than usual, but on the other hand, it's a little easier because we have a shell on the proper machine, then we have a GDB where we have an strace where we have Python 3 there. So yeah, it's a little bit more work than usual, but we are in a really comfortable environment, and it's pretty typical on hard exploitation challenges to just like fight with the challenge not behaving as it does in your GDB, not behaving as it does on your machine. So yeah, I'm not super worried. Like, this isn't unexpected. This is what kinda I expected going into this heap exploitation challenge. Now, I'm going to change this to an address which is absolutely doesn't make sense, 41, 41, 41. This should absolutely crash. I need to run it to see if it crashes though. And it crashes, which is good. Then I'm going to change it to what again, so it doesn't crash. I'm going to comment this out, and I'm going to change this to an address which doesn't make any sense. Okay, so let me do it like this first. This strace less didn't crash. There's like sick child, which is fine. Now uncomment this, so now the second address is bogus, and now it should crash too. And it did crash. This is good. This is good. And the address which it crashed, hey, this is fine. So we can confirm that this is +8. And this actually gives us some information. I didn't notice that before. So what happens if we do, like, let's just reverse it actually. And see this, what happens. And we get 4D. So yeah, the difference is between plus C and plus D plus 8. So this is the same as under a debugger. S-trace is a debugger, by the way, so that might be a problem. One thing I'm going to... Okay, no, I cannot do it. No, I can do it. I'm going to do this, and so now nothing should crash. I'm going to run it. I'm going to double check that it doesn't crash. So here, and we go to the end and doesn't crash. And now I'm just going to basically run my exploit without anything. And it doesn't crash. Perfect, perfect, perfect. This is good. Or at least it doesn't show that it crashed. It actually crashes, but it doesn't show that it crashed. So I'm going to do this again. And I'm going to see where it crashes, what kind of crash it is, and where does it crash. Python 3, no, S-trace. I need S-trace, I need less. And it crashes with this address. 4808D. Well, this is a weird address. Where did it get this address from? No, this is 4808. This is an absolutely weird address. Does it change? Here's the question. Does it change? If I run it again, does this address change in any way? It does not. Does this address look similar to anything? Yeah, it does look similar to this. Now the question is, where the hell does this 4 come from? Why is there a 4? Does it change the 08 to 4 for some reason? Am I doing something stupid somewhere in an exploit? Where? Show me the where. Did I do something stupid in the where? No. 2C D0 04 08. This is okay. And that's the where. So I put the where here. Can you actually tell me here, print? Okay, and I would love you to do where minus C. Okay, let's try CBFE, blah, blah, blah. Where? Yeah, this is fine. What is 08 in ASCII? Show me the ASCII. Is it something weird? 08, BS, that's backspace. Backspace isn't weird, that's a normal character. Or is it weird? It is weird. Because we are sending it through a console. But no, because we are not handling it. Because it's not a keystroke which we are sending. I'm going to change it to 09 and see if it crashes then. Because we might be like super close actually to the solution. With just like weird bug. Okay, so this is fine. Yeah, just like whatever, just give me the value here. This minus C, I guess I can handle. Yeah, minus C, and I'm going. Yeah, let's just stick with that for a second. Let's try less and go at the end. We have, yeah, the 4 is added here. The rest is fine. Now I'm going to change the 8 to 9. And I'm going to run it. I'm going to less it. And it crashed at 4809. Did I? Wait. That's weird. Why did this, like, that's weird. And I cannot change it to A, I can change it to like 2, for example, or 0. Let's change it to 0 and see what happens. Wrong application. Ashtrays less 48 and then 0, 0 and then 0. What does it do? The 0, 4 is supposed to be here. Like, this is untouched, right? But it put my 0 here. And it overwritten my... It's weird. Let's change it to FF. Because why not? What does it do? Why is it behaving like that? 48 FF. It shifts one that byte by 1. Why? If I put 08 there, wait, if I put 0, yeah. Why? What's wrong with 4? It doesn't like 4. If I change it to 5, does it behave a little better? 5, 08, 05. Alright, that's weird. Here's a 6 seg. Okay, so 05, yeah, this works correctly. It doesn't like 4. Why does it not like 4? That's end of transmission. Why? But I'm sending through a pipe. Is it something that Python is doing? Is Python annoying me? What can we do to test if Python is annoying me? We can run T. Let's run T. Okay, let's do the 4 here, and let's run T. Where is it? Perfect. Here we go. We are going to run, we do not care about this for a second. We are going to run T. And we are going to run it with home, ginveil, and yeah, T basically, everything it gets on standard input, it writes into a file. Okay. Let's trace. I think that's it actually. I'll reset LSLA and home ginveil. Did it write, or do I need to actually like... No, it didn't, yeah. It didn't flash the buffer. So I need to do I actually need to exit here. I'm going to write the data, and then after writing the data to T, I need to exit. And to exit, they said like something about OS error. In the file condition. Okay. Okay, so it does return an empty string, and this is in the file condition. Perfect. Yeah, just this. It does it. Okay, one more thing, actually. Wow, what the hell? No, come on. I am sending the exploit, but I cannot do this. So I cannot do this, so I need to do... Yeah, it goes here and then it goes into a read. I cannot do a read here because the read will hang. So org data it's B, sorry, it's B, A, like some number, and then, yeah, whatever. No, okay, now it should be fine. It's not fine? It's weird. And it hanged? Oh, come on. Yeah, it seems it hanged. Okay. So I'm going to switch here for a second. Okay, here we go. And so it's fine that it's hanged. Like, just tell me you generated, didn't generate. Okay. What do? We need to go to the same task directory again. And we need to play with home gunveil asdf.py. So this worked. I'm not doing any reads here. And I'm writing this, I'm returning this. Why did it just exit the process? Should be a binary string, an empty binary string. You know what? I'm kind of afraid about like losing connection again. I'm going to run it on screen. Python home gunveil asdf.py. Okay. Okay, I have to press Ctrl+C there for some reason. And yeah, it broke, which is fine because I'm on a screen. I don't care. And it doesn't work. Why are you not liking me? Let's do here. Let's just return 0, like an empty string, and see if this works or if it breaks. Screen dash D, was it? How do I force screen to screen? Oh. Whatever. Python home gunveil. Oh, actually. Okay. No, it seems that Python has there's some weirdness here. It doesn't actually allow the application to exit or does some other weird stuff. I have to read from the buffer. Maybe I have to read from the, but there is nothing in the buffer. I'd have to read from it. So can I kill a screen? Ctrl-KY, okay. Ctrl-KY. Yeah, I'm guessing it didn't work either. So, okay, let's just like scratch this idea. How can we make it? Home gunveil. Yeah, TV, that sounds perfect. Let's do it. Let's do one more try here. So we are running this. Now I don't care, this is fine. Just write it, just do this. Okay, this is fine. This is like, I can even output this data. This is fine because I'm going to make my own application instead. Okay, cool. Now t.c. And what we are going to do here is we are going to do two things, I guess. First is going to be printing the output. So this is the first thing we'll do. Okay, after this, we are going to open a file. Not this file, absolutely not this file. And we are going to put data there, and we are going to close the file at the end. And the data which we are going to put there is going to be from standard input. So we are basically in a loop while one, whatever. And we get a char, so int ch is f gets. What does this man f gets? Is there any weirdness here? No, just this. If ch is like less than 0 or ch is more than 255, then just break. If f eof of f, then break. I don't want an infinite loop here. Otherwise, we want to put c, right? Put c, yeah. F put c here, the ch, and flash f. So we are actually, yeah, like really gcc t.c. We are really like flashing the buffers. Okay, yeah, this is mighty now. Makes a pointer for integer. Yeah, I did look at man and I still failed. I'm terrible. Let's do it like this. Okay, that was fine. Okay, and now let's run it in screen, obviously, because I absolutely do not trust myself. Python. Yeah, okay. Okay, now something happened, which is good. And we still have a file of 0 size. Why? Okay, we are running gunveil-t. Let's just see if it actually works. So home gunveil-t. No, it doesn't. Why does it exit immediately? It shouldn't exit. Obviously. Yeah. Okay, let's just try to run it, then isdfpy. Okay, and it should be still fine, because now it should actually, the file should have been created. Yeah, perfect. Hex dump -c. So what's going on here? This is what it's receiving, and it's receiving what am I sending? That's a nice question. So let's do a new one. Beam a. I'm in a screen, so I can do this, like just switch. Okay, what am I sending currently? I am sending 0804 DO. Okay, so this is what I'm sending. And what I'm getting is 20 D008. Why am I getting 20 D0 at the first place? Like, this is the first question. How does it become so destroyed? And is this correct at least? It's the what, so it can be anything. So yeah, let's not do this for now. And let's actually rerun it. Okay. So now we are getting like this 50 BE0808 everywhere, which is okay, I think. This is the, yeah, I'm going to assume it's okay. Then we have the shellcode here, but here this is weird as hell. What's going on here? Is it because... No, seriously, what's going on here? It's okay, that's 20, D0. And then suddenly I have 08 instead of 04. And if I change this 04 to anything else, let's change it to 5. If I change it to 5, then it suddenly works. Otherwise, yeah, and it just doesn't send 04 through this pipe for some reason. Why? Python pte send 04. It's a TTY controls. What this means? Why? But this is a Python thing. This isn't. Yeah, it's like I kind of suspected this might be a problem. For some time now, and Sadie was right. Maybe I should just... Yeah, this is going to be like looking... Does use pawn tools? I don't know pawn tools. And the last time I tried to install it, it didn't work at all on my computer, so yeah, I'm going to try again. Yeah, I think we have to rewrite the code to actually use this thing. Because with this thing it should be actually... Okay, we can try to rewrite the code to do that. Are we going to write it here, or are we going to write it here? We can write it here. Okay, this is taking way too much time. So, okay, instead of this, we are going to do master slave and create a PTY device. I want the official documentation. Python OS open PTY. Yeah. No, no, no. Okay, now we are going for this one. Why are they not inheritable? This is kind of weird though, they are not inheritable. Okay, so we do this. Now we get a master and a slave, and we have to pass the slave to the child process, basically. I wonder if there's like a Python sub process OpenTTI. Okay, FD. Yeah, okay, I can do this. This is fine. So I do subprocess at the open, and yeah, we have this already here. We don't do this, we do this. Then we do what we do here, which is basically std in, slave, std out, slave, and okay, std slave as well. Is this needed? No, we do not need std in to be slave. This is fine. We can actually use an actual pipe. Hopefully, yeah, this hopefully should be okay. So this is the pipe. Okay, and this is P. Now here I'm actually going to do. I'm just going to do like this. I do not need this now. Oh my, that's absolutely not what I wanted to do. How do I even, yeah, okay. Okay, I do not need this. Now, I'm going to read from, so P std in. No, I need to read from master. So OS read from master the lines. Now do this. Now do this stuff and write. But we do not write here. We write in p std in. Right? We do not need this. We do need this. Okay. And now we need to get the date until the end, basically. So we do. We basically do OS read. Sorry, OS read, then master, then 1, and we get one character out of it, and we do it in an infinite loop. So infinite loop, because it should break at some point, but we do not care. So we do sys std out write ch and sys std out Right, what do I need here? I need to flash, because, yeah, reasons. Okay, and now let's check if it works. Where's my... Here we go. iPhone, ASDF. Okay, out of range. Just print it. What are we getting? Oh, we are getting something, which is good. But we are getting it immediately, which is too fast. Because we are getting the first line here. So let's do... This is the first line, this is the second line. So we want the second line. And we do not care about this anymore. We just do here org data. Strip. Okay, so we did get somewhere, I think. Where did we get? I want this. And I want this. Okay, now wait, something's weird. Why didn't hang now? But if I do this, it doesn't hang. Parentheses. Okay, let's do it a different way. Org data is this, while org data length of org data is less than how much was it? Like 48 basically. Then we do d equals 1 org data plus d, and then we do what we did before. So lines is equal to org data split lines, and here we do strip. Yeah, that's fine. Lines of the one actually. Print lines. We do print lines. Well, print org data. Just to be sure we are printing. Okay. Okay, this is fine. Cool. So it's getting this. Then are we getting the this part here? We are absolutely not using Python 3. Okay, here we go. Yeah, I was waiting for this. Print CH. Was it like this? Come on. I don't even. str. Why can't I? Yeah, like str ASCII. Does this work? Okay, so something works. And it freezes. Why does it freeze? Because hopefully it gets into... No, I don't know why it freezes actually. Why do you freeze? Is this not working? Why are you freezing? Are you waiting for something on standard input or what? Can I just like flash here? I don't get it. This is weird. It should actually get the data, right? The data is O joined. And sends it to standard input. Does it actually send it as trace fe trace equals read? Oh wait, it actually crashes, which is nice. So what we can do here is how do we exit here after it crashes. Do we care about it? No, we don't care about exiting, but crashes. Okay, cool. We can work with this. Let's go to the shell. Okay, and here we do cat sdf.py to overwrite it. Let's exit here. Okay, now we just run it. And we need Python 3. And we get the flag. Yeah. Come on. We spent like 1.5 hours fighting with weird implementation, like with a high-level implementation of sudo ppy inside Python libraries. Like, I seriously didn't expect master pipe to be interpreting any terminal sequences. Why would it? That's not how pseudo terminals work. Like, they have to handle it, but it seems that that library did it, and it changed what we sent to the process to gibberish, basically. And yeah, and we spotted that only after doing the T into a file, and that was annoying, and then we had to rewrite it to use low-level pseudo terminal implementation. Yeah, okay, but yeah, we have a flag. I didn't expect it to take so long, but I guess I learned something about Python, not to trust the PTI library because it does weird stuff. The next time we're going to solve a web challenge, I guess. I'm probably going to, web challenge and then the forensics, and another web exploitation and another web exploitation. So I think it's going to be easier from here. We have 21 challenges unsolved. Maybe some will unlock. If you have any questions, there are some questions. I'm going to still stay a couple of minutes and try to answer them. I am going to turn off the shell. Yeah, so I guess we figured out the heap overflow quite quick, but I failed at sending the exploit because the application didn't flash the standard output when it received the pipe, and this forced us to use a terminal, and I used a too high-level library for pseudo terminal instead of using low-level APIs, which turned out to be easier than I expected, actually, because I didn't know I can just straight up pass it to sub-process, but since I can, that's pretty amazing. And yeah, in the end, when we got that out of the way, our exploit worked like first try. Yeah, like I didn't even have to debug anything at that point. Oh well, oh well, oh well. But yeah, I guess I hope you at least learned something, even if it was painful to watch at the end of the day. Now, are there any questions? There are a couple of questions, so let's quickly go through them. The questions should appear here. Yeah, so it wasn't a problem with Python subprocesses, but it was the problem with Python PTY library. Subprocess was fine. Yeah, it was like nothing here was the fault of subprocess. It wasn't the fault of subprocess that we couldn't get the address initially, because that's just how buffering works in libc. Subprocess isn't at fault here. Okay, what resources do you recommend to start getting into heap exploitation from scratch? Any good tutorials, videos, step by step? Excellent question. I have some written down, but actually if you, wait, maybe the ones I have written down are still working and I can give you a link. Where did I have it written down? Okay, I guess I lost my link. But there are like full write-ups with... Oh, here we are. Never mind, I found it. Just because. Okay, they are opening, so I'm going to give you links in a second. Let me open the browser again. Okay, overview of malloc. This is the first one. I'm going to give you links on both chats. I hope yeah, this is working. Okay, so this is one link. I have. This is the second link. I know some links are from people who watched this live stream because I tried learning heap exploitation on some other live stream, and some people send me these links. So thank you for these links. These aren't the links which I found myself. I did find some of them, but not all of them. Yeah, I'm putting a lot of links on YouTube, a lot of links on IRC chat. Oh, this isn't related. This isn't related either. This maybe is related. Okay, so this is another one. This isn't. This is dead. Oh, this is actually a really good one. Yeah. And another one. Okay, I think I didn't show a couple of them on screen, so you can just pause the video, I guess, and transcribe the link if you like. No, that's it. Yeah. I guess you can find it just using the title as well. Okay, and did I show this one? No, I didn't show this one either. So this is the shellfish, how to heap. This is, yeah, probably the most important one. And one more. I already gave you the links on the chat, so yeah, understanding glib, cmalloc. So yeah, these are for. I have no idea about video tutorials. Like, as usual, check Live Overflow. Like, Live Overflow has a lot of cool stuff, and check all the other security streamers where they usually have a lot of cool stuff, so they maybe have something about heap overflow as well. How to protect code from debugging. First, you cannot, but if you still are thinking you can, there are like multiple tricks. It's like this. You can try to detect the debugger and then just exit the program or behave in a weird way if you detect the debugger. And depending on what operating system and you are and against what debugger you are trying to protect against, then there are different tricks. There are some tricks which work for a given specific debugger, like, I don't know, OllyDBG or GDB, and there are tricks which work for every debugger out there on a given operating system. Yeah, but I'm saying you cannot because most debuggers which are used for reverse engineering, especially malware, they have a lot of tricks implemented, like they bypass the detection. So you cannot detect them that way, and it goes into a cat and mouse game between the debugger developers and like the plugin developers and actually the people who are trying to protect against debugging. So that's one way. The other way is you can do time bombs because, well, that's not really a time bomb. That's more like timing detection. It's if you have, if you're on a debugger and you do a breakpoint, right? Well, then your application isn't running at full speed because it's like somebody just had a breakpoint. So like he stares at the code for a couple of seconds and then resumes. So what people do is if they have like some part of the code which they don't, like they believe a breakpoint will be set, they measure the time before that code and after that code. And if that time is like, I don't know, like in range of nanoseconds or milliseconds or microseconds, it's fine, because that means that the CPU was just working through it. And if it's like seconds or minutes, that means probably somebody is looking at it at the debugger and you therefore can detect them and kill the application or behave in a weird way. So yeah, and another thing is you can obfuscate the code and make it hard to reverse engineer even with a debugger. And as mentioned, none of these methods work. At the end of the day, if somebody puts enough time, they can reverse engineer your code. So if you are thinking about DRMing, then just don't bother. Like, put money elsewhere. Yeah, that's basically it. Now, again, it depends on the operating system what tricks can be used. So you have to, like, for Windows, you have to look for other tricks. For Linux, you have to look for other tricks. Very well documented. Like, there are a lot of tricks like that known. Just look for them. Go to Toots for You, I guess, like, and I'm pretty sure, like, Toots for You. And I'm pretty sure they have, like, heaps of papers about this. I have no idea which section that might be, but probably like tutorials, dissertations, and so on and so forth. And is there something like debugger and debugging? Yeah, you'd have to look here, but I'm pretty sure if something exists and is related to reverse engineering, is going to be on this website. Peter Fury, by the way, did a list of... Did he do a list of debugger detection? Yeah, the ultimate anti-debugging reference, exactly. It's pretty old, but it gives you an idea on Windows what tricks were used to detect the debuggers. So I'm going to just give you a link on the chats. Okay, the next one. Do you consider it worth learning buffer overflows in depth, considering all the security measures in place which are essentially eliminating them? They're not eliminating them. Like buffer. Okay, so it's like this. You have to learn a lot to exploit modern buffer overflows, but you still can do it. At the end of the day, it's still possible. You can still bypass almost any mitigation if a buffer overflow exists and the application is complicated enough and you have a complicated interaction with the application. So you can still usually exploit it. That being said, if you care about low-level exploitation, and this is where you want to go, you have to learn buffer overflow, and you have to learn all the modern techniques, all the modern bypasses. That's the way to go, basically, because, well, that's low-level exploitation at the end of the day. And yeah, if you do not care about low-level exploitation and you just want to do security, like, you can do other stuff, like web security is super interesting, and mobile security is interesting, system security, network security, and so on. You do not have to learn buffer overflow to, to be in security, because security is like a huge area, and for a lot of stuff you can do without even doing low-level exploitation. If you want to go low-level buffer overflows, yes, you have to learn them. Have you considered doing streams about game making and related topics, game jam tricks and hacks? I've done some already on the Polish live stream. I might have to... I would love to do some on the English one as well. Maybe after PicoCTF. Let's make a game, why not? I like it. Why don't you use Syslick? What's that? I have no idea what's that. Minecraft. Is this what, like, related to Minecraft? I have no idea what's that. Should I learn something? Okay. Yeah, I have no idea. So, Pawn tools, cyclic, Pawn tools, cyclic. Okay. Okay, because I'm not using Pawn tools. So, if you like Pawn tools and you use Pawn tools, absolutely use Pawn tools. As mentioned, it just doesn't like my computer, and I do not care enough about it to like spend several hours debugging why doesn't it like my computer. Yeah, but that's basically it. Like, that's one of the reasons. On the other hand, I have some of my frameworks which I use for CTFs, which are smaller, way smaller, don't have enough like such features, but they're enough, and I know how to use them, which I'm comfortable with. So that's basically why I don't use. If you use Pawn tools, that's absolutely good and absolutely great. Just do it. What are you doing? Speaking. I don't know. Well, I guess that question was like during the challenge, but I have no idea at which point it was asked, so yeah, I don't know. Okay, let's call today. I will stay for 5 more minutes on chat, and so you can, yeah, if you have any more questions, let me know. And thank you, Foxtrot Charlie, for being here, for being my moderator, and sorry that it like took so long today. And yeah, and that's it. So see you folks next week or tomorrow if you speak Polish, and we are going to continue PicoCTF. So yeah, stay healthy.